Hi, this is Tej Arora. I'm an AWS Certified Solutions Architect Associate. In the AWS Quick Learn series, I will cover AWS services and features in short videos. These videos will provide a quick 360-degree coverage of a service or feature. They are suitable for those preparing for an exam or an interview or just want to refresh their knowledge. In this video, I will cover CloudWatch. Let me start with an introduction. So, what is CloudWatch? It's a service that helps you monitor your workload's operational health, which includes how the resources are being utilized, how the application is performing, and alongside monitoring, you can also automate remedial actions if you see issues, and this way you keep your system running optimally. CloudWatch collects operational data from your application, from the AWS resources and services you use. And what is this data that it collects? It's metrics, logs, and events. We'll talk more about this later. Data can be collected as frequently as every second, and this data that you collect, you can visualize on dashboards and in graphs. There are built-in dashboards called automatic dashboards, and you can also build your own custom dashboards. What it helps you do is visually diagnose issues. If you see, for example, a spike in a graph, you can correlate that with information in the logs and diagnose issues that way. You can also initiate automated actions on the data by setting up alarms. So you can set up an alarm that is triggered if a threshold is exceeded. For example, if you want to be alarmed when your billing amount or your expected billing amount crosses a threshold, you can do that. You can also set rules to route events to event handlers such as Lambda, Kinesis, SQS, and SNS. Now, note that CloudWatch is an enabling service for every pillar of the well-architected framework. And it's also classified as a key service for the reliability and efficiency pillars. Now, essentially, the basic use cases for CloudWatch include monitoring your workloads and troubleshooting your workloads and optimizing your workloads. Now let's take a quick look at a diagram that summarizes the different functionalities. So in the center is CloudWatch, and it gets metrics, logs, and events through a REST API from AWS services and resources and applications. And REST API is accessed also from management console or a command line interface or an SDK. So you can generate custom metrics and your own logs and events by using CLI and SDK, as well as direct REST API. Now, what you do in CloudWatch is you have dashboards. You can analyze the logs and generate log metrics of your own. You can write rules to automate actions. You can generate alarms, and you can also generate scheduled events. And CloudWatch functionality can be summarized in these words: collect, visualize, troubleshoot, analyze, and respond. CloudWatch integrates with these various services when it initiates automated actions. So Lambda, SNS, SQS, Kinesis, workflow, and EC2 autoscaling. I'll get back to this diagram at the end of the video again, just to put everything into context. Now let's look at the key artifacts and concepts. They include metrics, logs, events, dashboards, and alarms. Now, metrics are either built-in AWS resource metrics, such as CPU utilization, number of network bytes in, etc. They can be collected at 1 to 5 minute intervals. Now, custom metrics, these are generated by the application, and they can have two resolutions. The standard resolution is the default, and that is at 1 minute intervals. But an application can also generate high resolution metrics, which can go as frequently as every second. Now, the retention of metrics, they are available once generated from 3 hours for high resolution metrics to 15 months for the 1 hour interval metric. The statistics that can be graphed for these metrics are sum, minimum, maximum, average, and count. So graphing and alarming is based on these statistics. So what is a metric composed of? A metric has a name. It occurs in a namespace. For example, EC2 metrics are in the AWS/EC2 namespace. And the namespace is to avoid confusion, where users should not be mixing up metrics from different resources in a single graph. And namespaces are also useful when you set up access controls. You can have access limited to specific namespace metrics. A metric also has dimensions. These are name value pairs associated with the metric, and there can be up to 10 of them. For example, for an EC2 metric, instance ID is a dimension. And dimensions are basically, they form a unique identifier for the metric. And you can aggregate across dimensions. For instance, you can aggregate across all instance IDs and get aggregate EC2 metrics. Or you can look at metrics from a specific instance. A metric has a timestamp, is the time when it's posted to CloudWatch. And finally, a metric has units like bytes, minutes, seconds, and so on. Now let's look at logs. Logs are generated by AWS or by applications. You can view raw logs for diagnosing issues, or you can process the logs and run analytics on them with CloudWatch Log Insights. We'll talk about it later. You can even create your own metrics from log data by using the metrics filters feature. For instance, extracting the errors metric by looking for the error keyword in log files. Logs can be exported to S3 for analysis by other analytics systems. Now you can retain logs forever in low-cost storage. A log stream is essentially the name of a data source, and a log group is essentially a group of log streams that share common properties such as, retention period and access control for the logs. Now, an event is essentially, it reflects the change in state of a resource, or you can have scheduled events. For example, if a file is uploaded to an S3 bucket, that's an event, and you can use that event to initiate automated actions. Now, what's the difference between events and CloudTrail information? CloudTrail essentially keeps API access history for resources, whereas an event is a change in the state of a resource. How do events compare with the config service? Config essentially gives you an inventory of all your resources and the history of configuration changes, and it notifies on configuration changes, as opposed to events which highlight changes to the state of a resource. Now, you can write rules to automate actions when an event occurs, and the actions include a call to a Lambda function or a post to an SNS topic, post to Kinesis, or invoking a workflow. And you'll note that CloudWatch events has now been folded in a separate service called Event Bridge. Dashboards are the most common artifacts you see when you go to the CloudWatch console. Essentially, you can manage graphs of various metrics in dashboards, and there's built-in dashboards called automatic dashboards that are based on AWS best practices. Let's look at alarms. You can set up an alarm on any metric that crosses your own defined threshold. So how do you set it up? You choose a metric, you choose an interval period for observation of the metric, you choose a statistical measure like max, min, average, sum, choose a threshold value for this measure, and then use the comparison operator, less than, greater than, less than equal, or greater than equal. And that's how you set up your alarm. And once an alarm triggers, it goes into alarm state, and it gets out of the alarm state, the next interval where the threshold is not breached. When an alarm is triggered, various actions can be specified. You can post to SQS and use any notification type supported by SNS, such as email. You can stop or terminate an EC2 instance if, let's say, the metric indicates a problem with the EC2 instance. Or you can execute an auto-scaling policy. If you see, for example, overutilization or underutilization, you can scale your system. Alarm history can be viewed for up to 14 days. And alarms can be in 3 states: OK state, alarm state, and insufficient data. OK means the metric is not breaching the threshold. Alarm means the metric has breached the threshold. And insufficient data means that not enough data is available for the interval to make a decision about the alarm. So in reality, metric at a certain point of time may not make it to CloudWatch due to network glitches. So when a data point is missing in an interval, how is that handled? So you can configure the alarm and define how to treat a missing data point. If you don't configure it, the default is that it's treated as missing and the alarm goes to insufficient data state. But you can also indicate a different way to treat missing data. You could say missing data can be treated as not breaching the threshold, or it can be treated as breaching the threshold, in which case alarm goes to alarm state, or you can just ignore the missing data. Now let's talk about the features in CloudWatch. So the logs insights feature, it helps do interactive analytics on the CloudWatch logs. Now, when a log is sent to CloudWatch, it automatically parses out fields from the log record if the logs originate from AWS or if the logs from the application are in JSON format. You can run powerful queries on logs using regular expressions, aggregating across keywords, filtering, and so on. You can view log data on a timeline to discover trends and patterns. And the results of the analytics can be viewed on dashboards, or they can be used to trigger alarms. The anomaly detection feature helps identify unusual changes in metrics. When an anomaly is detected, you can view it on the dashboard and you can raise an alarm. So how it works is there's machine learning applied on time series metrics data. It forms baseline patterns, and then on top of that, anomalies are detected. And the machine learning techniques applied behind the scenes are smart enough to account for normal seasonal variations, such as a specific day of the week or a certain season of the year. These variations are not triggered as anomalies. Contributor insights allows you to analyze time series data and provide info to you on the top factors contributing to performance issues. For example, you can focus on byte transfers to and from IPs, and you can see a list of the top IPs. You have to write rules for specific log events that are sent to CloudWatch. And this feature helps in quickly diagnosing and fixing operational issues. For instance, if there is unexpectedly high traffic from a specific IP, you can discover that and address it. Service Lens allows you to have a single pane view of the health of an entire application, the entire stack, including the experience of the end user of the application. It helps you isolate and diagnose performance issues. So if an end user sees a slow response, you can discover that. So Service Lens includes infrastructure monitoring, application monitoring, which includes not only metrics but request traces using the AWS X-ray service. And it also includes end user experience monitoring by using canaries, which tests all APIs and URLs of the application. The synthetics feature allows you to monitor web applications and APIs by setting up canaries so as to get the end user experience view. You can create canaries for specific flow points. For example, if you have a very sensitive flow, such as checkout in an e-commerce application, you can observe how checkout is functioning using canaries. When a canary observes a threshold breach, you can set up alarms and take automated actions. And you can also view the data from the point of breach, from the point of a breach occurring. And this data includes screenshots as seen by the canary, which simulates an end user. You can view logs, and you can view the HTTP request archive, also known as the HAR file. All this data helps you figure out root causes behind issues. The container insights is focused on container-based applications, so you can monitor and alarm based on issues. There are built-in dashboards or automatic dashboards providing metrics, logs, traces for container clusters and containers. And if you have an EKS, ECS, Fargate, or Kubernetes environment, then this is a good feature for you to use. There's some additional functionality in CloudWatch for EC2. Now, basic metrics from EC2 are sent to CloudWatch at 5-minute intervals for free. And these basic metrics include CPU utilization, local instance store read-write operations and read-write byte, network read-write packets and bytes. And these are just like many other services sending metrics to CloudWatch. But you can also enable detailed monitoring for EC2. And with detailed monitoring, there are some additional metrics sent at 1 minute intervals. And the additional metrics depend on the instance type. Now, these detailed monitoring metrics are considered as custom metrics and are chargeable. In addition to basic metrics and detailed monitoring metrics, one can install the CloudWatch agent and get even more metrics. So an agent collects metrics beyond basic and detailed monitoring. It has to be explicitly installed, and an agent can also be used to collect and send logs to CloudWatch. And as I mentioned, these metrics sent by the agent are treated as custom and are chargeable. CloudWatch is cross-account and cross-region capable. It provides this additional functionality. Metrics are regional and visible in specific accounts, but you can set up cross-account and cross-region visibility to view all the metrics in one account. So it is a recommended best practice to set up a monitoring account and provide appropriate IAM permissions for users to view all the metrics from all the accounts and regions from this account. Now let's look at some of the limits of CloudWatch. These are not all, but just a few sample limits. So in Alarm, you can configure a maximum of 5 actions, and per region, per account, per month, you can have at most 5,000 alarms. There can be 100 canaries per region, per account. You can have unlimited custom metrics, which are chargeable. Per dashboard widget, you can have 500 metrics and 2,500 for the entire dashboard. Let's look at the key factors for pricing. So for metrics, the number of custom metrics is one factor, and the number of API calls to get metrics is another factor in the costing. The number of dashboards and the number of standard and high resolution alarms and anomaly detections. As for logs, the amount of logs collected, the amount of logs archived, and the amount of logs scanned by Insights, which does analytics, factor into the costing. The number of events handled, and for the contributor Insights feature, the number of rules and the number of matches, the number of canary runs. These are all the factors which add to your costs. The free tier provides all the basic metrics, 10 detailed monitoring metrics from EC2, 1 million API requests per month, 3 dashboards with up to 50 metrics per month, 10 alarms, 5 gigabytes of log data, 1 contributor insights rule, and 100 canary runs per month. In terms of integrations with other services, note that every service sends metrics, logs, and events to CloudWatch. CloudWatch posts to SNS when an alarm triggers. CloudWatch runs EC2 auto-scaling actions, and it is integrated with IAM for authorizing the use of CloudWatch. It defines a set of permissions that can be used, integrates with CloudTrail to log all the API calls to CloudWatch. These are not all the integrations, but a few key ones. Now let's look at how CloudWatch facilitates the 5 pillars of the well-architected framework. From an operational excellence perspective, it helps you visualize the health of your workload, helps you analyze logs to identify operational issues, and it helps you automate remedial action when the state of the workload drifts from the desired state. For security, it has fine-grained permissions for the APIs, and this gives it a lot of flexibility for access control. The HTTPS endpoint enables encryption in transit. The analysis on logs helps identify security incidents. And note that CloudWatch Logs is PCI and FedRAMP compliant. In terms of reliability, it's a key service for monitoring and responding to application failures, and the responses can be automated. And it also helps respond to changes in load on the system. It improves efficiency as it's a key service to monitor performance and utilization and take actions to optimize. And it also supports VPC endpoint, with which you can have private connections between your VPC and CloudWatch, and traffic does not have to be routed over the internet. From a cost perspective, it helps auto-scale down EC2 resources when metrics show underutilization. This concludes an overview of CloudWatch. Let me quickly go over the diagram again so you can place all that I've talked about in context. So here's the CloudWatch service. It ingests metrics and logs and events over a REST API from AWS resources and services and customer applications. It enables these capabilities to collect data, visualize the data, troubleshoot your workload, analyze the data, and respond to situations and issues. The major artifacts in CloudWatch are dashboards, alarms, scheduled events, rules, log analytics and metrics, and CloudWatch interacts with these services to facilitate automated handling. This concludes the video. Thanks for watching the video. If you found it useful, please consider clicking on the like and subscribe buttons. If you can leave a comment about what you liked and what could improve, I would really appreciate that. Thanks again.